peralatan lainnya. Kami juga diberikan kebebasan dalam berkreasi dan berinovasi. Dengan banyaknya kegiatan mahasiswa, diantaranya ada klub robotika, klub UAV quadcopter, dan lain sebagainya. Kuliah di Teknik Mesin Universitas PGRI Semarang memang menyenangkan. Teknik Mesin Universitas PGRI Semarang, action to move the world!
Kami dari tim KBM Informatika Universitas PGRI Semarang. Jadi udah pada tahu belum KBM itu apa? KBM itu adalah kompetisi bisnis mahasiswa Indonesia.
Jadi ceritanya, kita dapat hibah dari Kemenristek-Dikti di tahun ini sebesar 14 juta rupiah di bawah bimbingan Ibu Mega Novita, salah satu dosen di Prodi Informatika Universitas PGRI Semarang.
Jadi di informatika kita akan diajarkan untuk membuat aplikasi berbasis website dan Android. Nah, selain itu kita juga akan diajarkan animasi dan juga desain grafis.
Selain itu, di sini kita juga diberi wadah sebuah informasi seputar sertifikasi di lingkup kampus maupun luar kampus yang diadakan oleh BNSP yang berkaitan tentang pembuatan website maupun Android.
Yuk gabung di Informatika Universitas PGRI Semarang. Ditunggu ya!
Di arsitektur UBIS, kita diajarkan bagaimana mendesain dan merancang sebuah bangunan. Seperti halnya bangunan sederhana untuk rumah tinggal, bangunan pabrik, bangunan multimasa, grace building, dan yang terakhir bangunan make-use.
Di arsitektur UBIS kita akan diajarkan bagaimana cara mendesain dari gambar manual hingga gambar digital. Untuk gambar digital sendiri, kita akan belajar menggunakan aplikasi AutoCAD, SketchUp, Revit, dan Lumion.
Di arsitektur UBIS kita diajarkan untuk merancang suatu bangunan yang berkonsep green building atau ramah lingkungan dan hemat energi.
Mari bergabung bersama kami di Arsitektur Universitas PGRI Semarang, Green Building for Better Living.
Salam kolaborasi karya, salam Elektro Jaya. Saya Anggun Haryanti, mahasiswa Teknik Elektro dari Universitas PGRI Semarang. Teknik Elektro Universitas PGRI Semarang tergolong baru. Namun meskipun tergolong baru, belajar di sini sangat mendapatkan fasilitas yang baik serta didampingi dosen pengampu yang berkompeten.
Selain itu, kami juga pernah mengikuti lomba kontes robot regional meliputi Jawa maupun secara nasional.
Mari bergabung bersama kami di Teknik Elektro Universitas PGRI Semarang. Salam kolaborasi karya, salam Elektro Jaya.
Anggun Desiana Sofa, mahasiswa Teknologi Pangan Universitas PGRI Semarang. Selama saya kuliah di Teknologi Pangan Universitas PGRI Semarang, saya banyak belajar hal baru. Saya dapat menginovasi produk yang belum ada di masyarakat, seperti ada kopi kulit pisang kepok, ada kopi, beras analog, dan tepung gembili. Bergabung dengan kami di Teknologi Pangan Universitas PGRI Semarang.
Fakultas Teknik dan Informatika unggul dan berjati diri. Wassalamualaikum warahmatullahi wabarakatuh. Yang cerah karena didukung oleh sumber daya manusia yang berkualitas dengan kualifikasi bergelar master dan doktor lulusan luar negeri dan dalam negeri. Fakultas Teknik dan Informatika mempunyai 6 program studi: teknik sipil, teknik mesin, teknik elektro, informatika, arsitektur, dan teknologi pangan. Keunggulan yang dikembangkan di Fakultas Teknik dan Informatika sejalan dengan revolusi industri 4.0, yaitu pengembangan Internet of Things, robotik, 3D printer, dan bidang-bidang lain yang dibutuhkan di era milenial ini. Bergabunglah bersama Fakultas Teknik dan Informatika. Kami siap membina, membimbing, mengarahkan menuju masa depan yang cerah.
Nama saya Lutfi Arianto dari program studi teknik sipil Universitas PGRI Semarang. Memperkenalkan bahwa program studi teknik sipil itu sangat saya banggakan di sini. Mengapa demikian? Karena program studi teknik sipil memiliki dosen yang berkompeten di bidangnya. Selain itu juga di teknik sipil memiliki alat-alat di laboratorium yang sangat lengkap. Salah satu kegiatan di lab UPGRIS adalah penelitian dengan uji beton. Kita bersama dengan dosen dan juga teman-teman dari teknik sipil, kita akan memperkenalkan apa itu uji beton, kita lihat bersama-sama. Selain uji beton, di sini juga ada uji tanah. Mahasiswa bersama dosen sering melakukan pengujian tanah dengan sampel yang tersedia di sini, lalu kita uji menggunakan alat seperti di belakang kita seperti ini. Selain praktek di laboratorium, kita juga sering praktek di lapangan. Salah satunya adalah praktek teodolit. Mari bergabung bersama kami di program studi teknik sipil Universitas PGRI Semarang. Ternyata saya tidak salah pilih masuk ke program studi teknik mesin Universitas PGRI Semarang. Karena di sini alat-alat laboratorium sangat lengkap dan juga didukung dengan dosen-dosen yang sangat berkompeten. Di laboratorium teknik mesin Universitas PGRI Semarang memiliki alat-alat seperti milling, CNC, bubut, uji tarik, uji kekerasan, serta dilengkapi dengan peralatan-peralatan lainnya. Kami juga diberikan kebebasan dalam berkreasi dan berinovasi. Dengan banyaknya kegiatan mahasiswa, di antaranya ada klub robotika, klub UAV quadcopter, dan lain sebagainya. Kuliah di Teknik Mesin Universitas PGRI Semarang memang menyenangkan. Teknik Mesin Universitas PGRI Semarang, action to move the world!
Kami dari tim KBM Informatika Universitas PGRI Semarang. Jadi udah pada tahu belum KBM itu apa? KBM itu adalah kompetisi bisnis mahasiswa Indonesia. Jadi ceritanya kita dapat hibah dari Kemenristekdikti di tahun ini sebesar 14 juta rupiah di bawah bimbingan Ibu Mega Novita, salah satu dosen di Prodi Informatika Universitas PGRI Semarang.
Jadi di informatika kita akan diajarkan untuk membuat aplikasi berbasis website dan Android. Nah, selain itu kita juga akan diajarkan animasi dan juga desain grafis.
Selain itu, di sini kita juga diberi wadah sebuah informasi seputar sertifikasi di lingkup kampus maupun luar kampus yang diadakan oleh BNSP yang berkaitan tentang pembuatan website maupun Android.
Yuk gabung di Informatika Universitas PGRI Semarang. Ditunggu ya.
Di arsitektur UGRIS, kita diajarkan bagaimana mendesain dan merancang sebuah bangunan. Seperti halnya bangunan sederhana untuk rumah tinggal, bangunan pabrik, bangunan multimasa, UGRIS building, dan yang terakhir bangunan make use.
Di arsitektur UGRIS kita akan diajarkan bagaimana cara mendesain dari gambar manual hingga gambar digital. Untuk gambar digital sendiri, kita akan belajar menggunakan aplikasi AutoCAD, SketchUp, Revit, dan Lumion.
Di arsitektur UGRIS kita diajarkan untuk merancang suatu bangunan yang berkonsep green building atau ramah lingkungan dan hemat energi.
Mari bergabung bersama kami di arsitektur
Okay, good morning. Assalamualaikum warahmatullahi wabarakatuh. Thank you for ladies and gentlemen for attending on our webinar series. Today is a special day for Indonesia. Before the webinar started, I want to say Happy Independence Day to Indonesia. All activity will be paused for 3 minutes for the flag raising. Let me introduce myself. My name is Muhammad Budi Haryono, a member of the Department of Mechanical Engineering. I'm a moderator in the webinar today. Before today, we have been successfully organized the first webinar at last week. We have 6 events of webinar series. If you're interested to join our webinar series, you can also join in another event in our webinar series. And then I want to read our webinar rules to participants. The first is the Zoom application open 30 minutes before the event starts. All participants must have entered the Zoom application after 5 minutes of opening. All participants must turn on the camera and turn off the microphone. Certificate will be shared in the middle of the event via the link. The question session is divided into 2 sessions. Each session contains 3 questions. Asking questions through the comments column and include the name, and there will be several questions that will be given the opportunity to ask directly. And the topic for today is a cooling technology. My pride to introducing our keynote speaker today. The first speaker is Associate Prof. Sheikh Ahmad Zaki Shah Salim, PhD. He is head of Department Mechanical Precision Engineering, Malaysia Japan International Institute of Technology, University Technology Malaysia. She was graduated in Kyushu University, Japan. And the research focus is urban climatology, urban heat island, building, environmental engineering, wind engineering, CFD, thermal comfort. He was published 25 papers in WAS, 43 papers in Scopus, 64 proceedings, 1 patent, and 1 original book. Also, he received 9 awards. If you're interested with Dr. Sheikh Ahmad Zaki, also you can contact in his mobile office, or you can check in website, and also you can send email. And the second speaker is Assistant Professor Irna Fariha, PhD, member in Department of Mechanical Engineering, Universitas PGRI Semarang. She was graduate PhD from Tokyo University of Agriculture and Technology, Japan. After he held PhD, he did postdoctorate in mechanical engineering, Celal Bayar University, Turkey. She published a 6 paper. Participant will have a question can write in our chat room. And now I will give a time for Dr. Sheikh. Time for you.
Hello, Assalamualaikum.
Waalaikumsalam warahmatullahi.
So we can start now.
Yes, you can share your PPT and start your presentation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And also very good morning. And also very I want to wish for the Independent Day for Indonesia also as well for today. So my voice is clear or not? My voice?
Yeah, clear.
Okay, let me start. The topic is about challenges of seeking for affordable cooling strategies for built environment in hot and humid climate. So my name is Sheikh Ahmad Zaki, head of a wind engineering laboratory and also head of mechanical precision engineering department in Malaysia Japan International Institute of Technology, MJIIT, University of Technology Malaysia Kuala Lumpur. So let me introduce the several of my previous research in my lab. Okay, this is about urban climatology and wind engineering. So in this study, we want to know the effect of building shattering, how this one will reduce the wind velocity and obstructed the wind flow in the urban area, then can cause the poor urban ventilation. Before we propose any cooling technology in the hot and humid, we need to understand the problem in our climate and also our urban morphology. So this one is one of the my PhD student, okay, project. Okay, this one, okay, this project is about the numerical simulation, okay, of the building shattering effects, okay, and analyze urban area of various geometric condition using the large eddy simulation, is a CFD. Okay, in this study we propose semi-empirical model for the random array. Okay, with this model, we can estimate the wind-induced ventilation, the CP, because the CP will affect, you know, the position of the window. Even to know the position of window, okay, we need to know how to estimate the CP first. Okay, this one the second of my student project. Okay, this project is about the numerical simulation on the influence of idealized terrace houses renovation on wind pedestrian. Okay, we know the construction of new building or modification of original building. Okay, in Malaysia, they have no certain local authority or rule how the people can renovate from the normal to the extreme renovation. This might be affect the wind, okay, ventilation in the pedestrian or inside the house. That's why we propose, okay, the study using the large eddy simulation. Okay. In this study, we simplify the terrace house, okay, with the normal one, and also with the small roundness, we call as secondary roundness in the square layout and also stagger layout to understand how the small renovation will affect the wind pedestrian. Okay. This one, the third of my research group, okay, project. Okay, in this project, okay, the research is about the numerical simulation of wind-induced, okay, ventilation in building with different opening configuration. We want to know how the position or combination of opening with surrounding building will affect the ventilation rate, because we know this is very important for the building to decide, okay, the combination of opening
Sorry, we have a problem with internet connection, so I'll postpone. I think you can wait, Dr. Share.
Halo, Mr. Budi. Mr. Budi.
Yeah, I'm here.
Yeah, okay. Dr. Shea already come. Okay, okay.
Sorry.
Okay.
Okay, sorry for the trouble because I already changed the Wi-Fi connection using another one. Okay, sorry. Okay, this one also several of my project in terms of thermal comfort. Okay, we conduct the thermal comfort in the hospital to estimate the comfort temperature for the patient. Also, this one another project in the between Malaysia and Japan. Okay, we examine the thermal comfort of occupant in the cooling loop mode and also with the free running mode in Japan and also in Malaysia. Because in Japan they already conduct the cool breeze campaign is 28 degrees set point temperature. Then also we compare with the data in Malaysia also. Okay, we want to propose the cool breeze Malaysia. Okay, another project also we conduct also in 4 countries. Okay, in Malaysia, Indonesia, in Bandung, Singapore, and Japan to examine. Okay, to estimate the comfort temperature with different ventilation mode, is a cooling mode, using the mixed mode and also free running mode is natural ventilation. Okay, this one also another project we conduct in Malaysia and Japan is in the classroom. We determine the comfort temperature for the classroom in Malaysia and also in Japan during the summer season in Japan. Okay, let me introduce for the content for today's presentation. Okay, for the research background and objective, we study in Malaysia survey on occupant behavior toward air conditioning and energy usage, field measurement, okay, of indoor thermal environment of terrace house and experiment of sleep quality and thermal comfort during night time. Okay, let me introduce the background of the study. Okay, I would like to explain the background of my research. As you know, the global warming and climate change are pressing issue of the world, particularly this year. Okay, extreme high temperature, heat wave was observed all over the world causing by the heavy causality. In fact, past studies show that heat-related mortality exponentially increase. You see this graph, okay? As you know, Malaysia and also Indonesia is located in an equator tropical region. Therefore, it is a certain that Malaysian people will be exposed significant health risks all through the years near future due to the global warming, frequent heat wave, as well as the urban heat island phenomena. Therefore, thermally resilient living environment is essential, okay, for our climate. Okay, but okay, if we try to take adaptation measure against heat risk, they will cause the increase of air conditioning use. Okay, for example, if we just use the air conditioning, okay, the energy use will increase as well as the green, okay, gas emission. Okay, that's why, okay, we want to propose, okay, a science-based national strategy to provide thermally adaptive living environment with Malaysia people at minimum cost, minimum energy use, and minimum emission is extremely important. Okay. So we know that there are several existing technology in Europe, North America, and Japan are fully optimized to meet latitude climate, high economic level, mature energy infrastructure, and Western lifestyle. Okay, therefore, there are two extravagant function, quality and cost. As a result, they are not
Sorry,
affordable in Malaysia.
sorry, Dr. Chef. This is a time for flag rising.
Okay, thank you.
Please, you can stop screen.
So I can continue. Okay, so I can continue my presentation. Okay. So now, although they have existing technology, okay, cooling technology in Europe and other country, but we know, okay, it is, okay, it's not applicable for the Malaysian environment, okay, because we want to provide with the for Malaysian people with the minimum cost, minimum energy use, and minimum emission is extremely very important. That's why we cannot simply adapt the existing technology in others country. Okay, in order to achieve the target, okay, first we need to understand to have the database of the Malaysian people. Okay, that's why we conduct the field study aiming for sustainable built environment in Malaysia. So we conduct a survey of air conditioning, AC, and energy usage in residential building. The objective is to grasp the lifestyle, how the people in Malaysia, okay, using the air conditioning for the cooling purpose. Okay, and second, we also conduct the field measurement of indoor thermal environment of a terrace house to find what is the affordable passive cooling method. And the third, experiment of sleep quality and thermal comfort during night time in order to reduce the AC using during the bedtime. So we conduct the survey, okay, not only in the Malaysia, the same survey also conducted in my collaborator in Japan. So we conduct the survey in Malaysia, 38 dwelling, okay, for the apartment house, okay, we install the thermometer, okay. We also install the energy meter to monitor the, okay, the AC, the total energy consumption for the house and also the electricity of the air conditioning. Okay, we install the smart meter. Okay, so this one is the household profile, okay, from the Malaysia house. Okay, it consists of the number of household, room measure, and household composition. As we can see here, from 2 people until the 7 people. Okay, they are stay in one dwelling. This one is a household profile. Okay, we categorize in the 3 group: senior couple, single income family, and also dual income family. So when we compare the outdoor temperature between the Malaysia and Japan, we can see in a hot and humid climate, okay, a little seasonal variation, almost constant the temperature. Okay, in Japan, we only compare the result in the summer season. It's almost similar with the Malaysia. This one is the raw data of the observed AC electricity in Malaysia. Okay, we compare among 3 dwelling. Okay, for 9 hours, we can see here different pattern among day and houses do the diverse behavior of people of Malaysia, how they use the electricity. That's why when we to propose any technology, we need to understand the data of the people in Malaysia first. So this one is the data of daily hours of AC usage of each dwelling. Okay, we can see highly diverse among houses. Okay, the YAZ is the average number of AC event in a day. Event mean, okay, the people turn on the aircon. When the people turn on until turn off, we call as a one event. So per day we can see from 1 until to 4 event per day that people turn on the air conditioning, and the average daily of hour of AC usage in the x-axis. Okay, so we can categorize this one in the 3 group. A is a frequent user of the air conditioning, B is moderate, and C is the rarely used. So this one we see the correlation between the daily hours of AC usage, okay, and also the outdoor air temperature. In the Kuala Lumpur, we can see the little seasonal climate variation, okay, but occupant, okay, AC usage is affected by daily outdoor, although they have small, but they have effect of the outdoor. People use the air conditioning also have some effect of the outdoor climate. In Japan, it's very clear the relationship between the outdoor because in Malaysia sometimes they doesn't matter whether the outdoor is hot or not hot, they still use the aircon. But certain people, they are using the aircon based on the outdoor air temperature. So this one is some general variation of AC usage among the dwelling. Okay, we measure in the living room and also the bedroom. Most of the people using the air conditioning during the night time in Malaysia. Okay, AC is mainly used at night time. Effective cooling strategy at bedtime are important. So if we want to introduce any cooling technology, we need to propose during the night time or bedtime. Okay, not necessary to introduce during the daytime because no one use the air conditioning during the daytime. So this one is the second project. Okay, the field measurement of the indoor thermal condition of a terrace house to evaluate the passive cooling strategy. Okay, whether passive cooling method other than mechanical cooling can achieve thermally comfort indoor environment. For example, we introduce natural ventilation, shading and insulation of envelope. So in step 1, okay, we propose four cases because we want to understand whether the natural ventilation method as a cooling method is possible in hot and humid climate. We propose fully ventilation, day ventilation, and night ventilation. All windows will open for 24 hours for fully ventilation. Day ventilation from 8 a.m. to 8 p.m. Day ventilation 8 p.m. to 8 a.m. It's a control case, it's without ventilation. All windows were closed. We also use another mixed mode. Okay, for the second floor, we, in this situation, AC, air conditioner or ceiling fan were used for first floor. Step 2, we propose the low cost retrofitting. It's the 24 hours natural ventilation plus roof cover. Okay, or fully ventilation plus roof cover plus ceiling insulation. This one is the investigated house. Is a typical house in Malaysia. It's terrace house. Almost 37% or 36% of total living quarter in Malaysia. Okay, they are used the terrace house. So we conduct in the one of the terrace house. Okay, 2-story terrace house in Kuala Lumpur. Then we install the instrument in the house for all room inside this house. Okay, we measure the thermal recorder, okay, hot wire to measure the velocity, and also we measure inside the attic, okay, the profile of the temperature by using the thermocouple. We also set up the local weather station, okay, outside of the house. We install the profile of the air temperature, wind speed, and also solar radiation. So this one is the result of air temperature with and without ventilation that we installed in the bedroom, dining room, master bedroom. You can see here outdoor air temperature during the measurement period is 24 until 38 degree. For the fully ventilation, we can see the range of the temperature is from 27 until 36. It's without ventilation, 1 degree higher. You can see 28 to 36. Okay. You can see the graph of solar radiation here. Okay, during daytime, okay, you can see that the air temperature is very high. Although we propose several ventilation, but the temperature is still high if we want to apply the natural ventilation in hot and humid. This one is temperature difference between room temperature and outside. You can see from this graph, okay, the room temperature is higher than the outdoor temperature. Okay. Without ventilation and full day ventilation, almost okay, similar the result. Okay, so we noted that interior space, okay, is always warmer than outside, especially at night time. Okay, natural ventilation can slightly improve the indoor thermal condition during night, but still not enough to realize thermally acceptable level. People still need to use the air conditioning. Okay, that's why natural ventilation might be not suitable if we use only natural ventilation. So we can see here the vertical distribution, okay, of the mean air temperature, okay, for each room. So we notice, okay, near to the attic, okay, near to the roof, it's very high temperature. So the key point here, we need to reduce the heat gain from the roof, okay, not from the side or the wall of the building, but the main key point in the hot and humid in Malaysia, we need to reduce in the roof. That's why we conduct another measurement to propose the low cost retrofitting for cooling strategy. So we have a 4 stage here. We repeat again full day ventilation, but we only conduct in the master bedroom because master bedroom is the high temperature compared to others room. For second stage is a fully ventilation with retrofit roof cover. And third is a full day natural ventilation with roof cover and heat insulation above the ceiling. And the fourth, we combine all the cases and we put also the ceiling fan, because ceiling fan is popular in Malaysia, I believe also in Indonesia. So this okay, the diagram of the 4 cases. In natural ventilation, okay, natural ventilation with roof cover, natural ventilation, roof cover and heat insulation. And also we add ceiling fan here. Okay, this one we install all the instruments similar with the stage 1. Okay. This case 1 is only natural ventilation, open the window 24 hours. Okay. So the second case, okay, we propose retrofitting roof cover. Okay. We install the roof cover in this terrace house, okay, with the air gap, okay, in order for the circulation of air through the air gap, okay, around 600 millimeter. But the material we use for this study only the light garden net, okay, it's a 90% blockage, okay. So this one we install also thermocouple, okay, inside this material, okay. For the third cases, okay, we install the ceiling insulation rock wool, okay. The fourth, we just turn on the air conditioning, turn on the ceiling fan. So we notice the effect of roof cover on surface temperature of roof tile. Okay, you can see this graph of temperature different y-axis, the different temperature between the roof surface and also the outdoor air, and also the solar radiation. You can know the solar radiation is during the night time is 0. Okay, it's a no effect. During the daytime, you can see that without the retrofitting, okay, the temperature difference is very high compared to with for the roof cover. They already reduced. Okay. This one we compare the effect of retrofitting on convective heat plug. Okay, you can see the average heat plug in attic, okay, is decreasing, okay, from 50 to 65 to the range of the 50 to 65 watt per meter square, almost 60 to 70% reduction of the heat plug, okay, in the attic as well in the room. Okay, also reduce the blue color line here. You can see also reduce 88% when we install the roof cover. So the roof cover is very effective. So the people inside the room feel more comfortable, okay, when we cover the roof with the air gap. So effect of retrofitting on convection heat plug with warm air of attic. You can see the graph of convective heat plug, okay, of inner surface of roof. Okay, drastic reduction of heat gain of attic, okay, when the solar radiation is increased here. Okay, you can see here the roof cover can reduce the heat flux. Okay, so this one is another graph of effect of retrofitting on convection heat plug with one of air attic with the RC is roof cover plus a ceiling insulation. Okay, when the equivalent outdoor temperature greater than 30 degree, you can see the roof cover, okay, we reduce the heat plug. Okay, so this one is a comparison of room air temperature between with and without roof cover. We can notice that reduction of 6 degree of air temperature in attic. So that's why the room air temperature will reduce as well. In the bedroom, we notice 1.5 degrees Celsius reduction of the temperature. So interpretation of this project, we can use cutting-edge smart roof, high quality of the cooling technology, rooftop PV as well. But whoever or affordable to use this technology, maybe high-income people only able to use this technology. So that's why in our group of research, we want to target for the middle, income people or low-cost people. Cheap and low technology solution can contribute to reduce heat risk, energy use, and emission by using not only natural ventilation, but also ceiling insulation and maybe new technology of roof cover. For affordable smart house. Our last experiment is experiment of thermal comfort and sleep quality, because we noticed, most people in Malaysia, they use more energy during bedtime because they need to turn on air conditioning with the low set point temperature, basically low than 20 degree. That's why we want to conduct the experiment to reduce AC use at bedtime. So during this experiment we conduct in UTM campus, respondent is 10 male and 10 female. 3 night for the each case. The case 1 we call as baseline. Respondent can freely use AC at any set point, the standard cotton bed cloths. Case 2, AC set point is 3 degree higher than case 1. We increase the set point and we use the special cool bed padding produced by Japanese company. We want, because in this study we just want to know whether is we propose some cool bed liner. Maybe in future we can produce our own cool bed liner, whether they will the people can get the good sleep quality and also thermal comfort. At the same time we can reduce the energy consumption. So we conduct, we install all instrument. We install also the instrument to measure the energy consumption, and to monitor the sleep quality we use the actigraph. So this is the setting of the experiment. We use the ordinary bedding setting without cool bed liner, and we propose some cool bed liner. We also conduct the questionnaire survey based on ASRE 55. We also record the amount of cloths, setting of bed cloths. Then this is the result of the room air temperature of case 1 is baseline. The people freely can set the air conditioning. You can see, the respondent, decide set point of temperature is different. For female and also male, the air temperature based on the set point also different for each people. From 17 until 27. This one is the result of the based on the questionnaire survey we also conduct. We noticed that respondent perception toward thermal comfort and sleep quality is comparable between two cases. The first cases people freely use, and the second papers we increase, but we provide the bed cool liner. We believe if without any thermal adaptation, people might be feel uncomfortable. Then by using these two case study, we notice people can tolerate, and the energy consumption we can reduce 38%. So concluding remark, if we study in Malaysia, we already can grasp the lifestyle, how people use air conditioning. And also for the second, we find the affordable passive cooling method. And the third, we notice that cool bed liner might contribute to reduce AC use during the bedtime. We know if we use the high precision of the air conditioning system, we believe they can reduce energy consumption, but who effort to buy this high precision of high technology of air conditioning? Because our target for the low cost or middle income people, that's why we propose some affordable method. Thank you for my presentation. Also thank you for your kind attention.
Okay, thank you for Dr. Sheikh. Interested a topic for cooling technology. If a participant have some question, you can writing in our chat column. During waiting, our team collecting some question. Maybe I want to ask some question. How to manage your research during Corona pandemic? Is it going well?
Okay, thank you for your question. Yeah, during the COVID-19, because most of my my research using field measurement and also experiment, but I also extend my research using the online questionnaire survey to understand how the people in Malaysia, okay, before the COVID, during the COVID, after the COVID-19, or they use the air conditioning, okay, how the thermal adaptation behavior inside, because during the COVID, people need to stay at home and working at home. Okay, before COVID, they are working at their office. They are freely can use the energy consumption, can use the air conditioning freely without thinking about to pay the utility bills. But when the people working at home, they need to to know that they need to pay the electricity, that the behavior might be changed. Okay, they might be more energy saving. So we conduct the kind of the survey around 1,000 survey, okay, online survey. This is why how I continue my study by using another method to understand the cooling strategy inside the house. Okay.
Okay. Maybe no question. If no question, I want to continuing the Dr. Irna. Yeah, okay. No question. Dr. Irna, you can start your presentation. Okay, time for you.
Okay, can you hear my voice?
Yes, I can hear your voice.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, dear all participants. Today I'm going to talk about the cooling technology, but actually today I would like to talk more specific about the thermoacoustic cooler driven by a thermoacoustic engine. Okay, in my talk, I divide it into 5 parts: energy crisis, thermoacoustic engine, environmentally dangerous cooler, thermoacoustic cooler, and thermoacoustic cooler driven by thermoacoustic engine. Now, I would like to talk about the energy crisis. Over the last 2 centuries, energy needs have skyrocketed dramatically, especially because of the transportation and industry sector. However, fossil fuels are polluting and their reserves are limited. We know today that these resources are close to exhaustion and our societies are facing a major challenge. The energy crisis stems from the forcible end of the cycle of oil, gas, and coal, which in addition have been producing a considerable increase in the greenhouse gases. And then the massive use of traditional energy sources leads, among other things, to the increase of greenhouse gas emissions, such as carbon dioxide, resulting in global warming and harming the environment and biodiversity. Therefore, the energy crisis is closely linked to the environmental crisis. And then the, yeah, sorry. So, so because of the crisis, so yeah, we know that there are many ways: heat energy, and then the solar energy, and then waste heat energy, and then the geothermal energy, and then we can use this for the power of the engine, and then we can use it for the thermoacoustic engine. This is I would like to show you how the thermoacoustic engine works. So at first we can put the heated the first side of the we have a loop tube. We have straight tube, and then in the straight tube we have a hot side, and then this one ambient side, and then inside this one is the stack or the regenerator, and after that it can produce the acoustic power, and then the acoustic power can be used for like how, yeah, this one is working. So when okay, when we put the heated the first side, and then the other side is cold or ambient temperature, and inside this one is how to say regenerators or stack, and then we can produce the acoustic power, and then acoustic power can make this moving, and then the power can be used for example, like electricity or to power the refrigeration. You can see here, yeah, it's very simple about the thermoacoustic engine. So it work how to say, like it's combined between the heat and then the acoustic. Yeah, it's working. So here I would like to show you how does the thermoacoustic regenerator works. So actually, if I draw this the engine, we can see here that this part is the hot side, and then this part is the cold side, and then this one we can call it actually the regenerator. And then when the hot side is heated, and then the acoustic power would be produced because of the oscillation inside the gas oscillation inside the stub. And then this one I would like to introduce you about thermoacoustic, because maybe some of you this is the first time for hearing about the thermoacoustic. Actually, the thermoacoustic is combination between thermal and the acoustic. Thermoacoustic is interaction between temperature, density, pressure variation, and acoustic wave. And this one, when we talk about sound, we talk about the longitudinal wave. As we can see here, that the particle inside the tube is moving because of the wave, because of the power. So we can see here that this power is moving, and then this is the wave, and then there is a compression and rarefaction. This is the science behind of the thermoacoustic. And now I'm going to show you the application of the thermoacoustic engines. A thermoacoustic engine can be applied for the thermoacoustic electric power. When we talk about the engine, we know that the engine can be used, how to say, like it's very beneficial for make easier for our life. For example, when we see here, this is produced by Aster, like startup in the Netherlands. This one is acoustic thermoacoustic power. So one is the engine and the other uh, it can be one, two, or three engine, and the other is the electric power. So the engine can be used to power the electric power, and the right side is how to use the engine for the cooling, for the cooler. The right side is there are three stage of the engine, and the other is cooler. So the engine work to power for the refrigeration. Here I would like to show you the conversion of heat into the electricity. This is from the Aster in Netherlands. So this one, the low temperature heat exchanger, we have two heat exchanger, and this one, the regenerator. This is the heart of thermoacoustic, and this one, the high temperature heat exchanger. So we have two heat exchanger, and this one, we need the acoustic traveling with the feedback. And then this is the linear alternator. Okay, the power generation start. Yeah. This is devices that we use for the electric power generation from the thermoacoustic. We can disconnecting, stop the power, and we can measure the electricity, the current, and so on. As you can see from this video, and they expand the system for four regenerator units, and then make it possible to utilize the lower. So this is, as you can see, that the waste heat temperature is increased, and then we can see that this is use waste heat, and then the result is the electricity. This is built in the Netherlands. This is already built. Okay. Okay, so at first we talk about the engine, the thermoacoustic engine briefly. And then now I'm going to talk about the environmentally friendly cooler. So I'm trying to connect between the engine and the cooler. At first, when we talk about the cooler, we remember that we know that at home we have a refrigerator, and then we have an air conditioner, we have a refrigerator truck, and also refrigeration industry. And then the most of them, some of them still use chlorofluorocarbon or freon that make ozone depletion layer. It's not good for our life. So we need the alternative technology for cooler. So in this case, we propose for the thermoacoustic cooler. So this is a thermoacoustic cooler. At first, actually, we can use like electrodynamic philosopher. This one, we talk about the thermoacoustic cooler itself. I didn't connect with the engine. At first, we can produce the sound from the electrodynamic loudspeaker, and then using this, we can put inside, we can put the regenerator or the stock, and then there are two heat exchangers. The first is ambient heat exchanger and cool heat exchanger, and then the heat can move from hot side to the cool side, or cool side to the the cool side to the hot side to remain the one part is keeping cool. And then unfortunately, in this case, we still use the electrodynamic loudspeaker. It means we need energy or power from the outlet. So it's how to say, like it's not support for saving energy. So we need renewable energy like solar, geothermal energy, and waste heat energy from industry or from the transportation. Uh, okay, so now I'm going to connect between the thermoacoustic engine and thermoacoustic cooler. At first, talk about the thermoacoustic engine, and then after that, I talk about the thermoacoustic cooler, and then after that, I would like to combine between a thermoacoustic engine and thermoacoustic cooler because at first, if the cooler using the loudspeaker, so it means it's not safe for the energy. But in this case, if we build like this one is how to say the device is built by Aster in Netherlands in 2019, and then in the right side is from our lab when I was in Japan. My lab is Ueda Lab at Tokyo University of Agriculture and Technology, Japan. It was built in 2018. So those almost the same, but we have a different geometry because at first, when we see for the, how to say, when we see for the right side, we can see that there are four for I mean like 3 engine and 1 cooler. That's almost same, but it is one 3 engine and 1 cooler. At first, before we construct that the devices, actually we already did the optimization because we need to make sure that the devices work efficiently, and then in the future we can use commercially. So in my laboratory, we did optimization of thermoacoustic cooler driven by thermoacoustic engine because optimization is very important to make sure that the efficiency is very good, and then in the future we can use for the commercialization. And then this is some of my publication related to the numerical calculation and also calculation of the energy conversion. And then we calculate all of the effect of the process. And then this one also my publication related to the geometry, related to the effect of the cooler and the engine. And then in this year, 2020, in Netherlands, they already built the new rooftop installation of sound energy thermoacoustic cooling system. So it's already applied in one of school in Netherlands. So this one, as you can see here, this one, there are 1, 2, 3, 4. So this one can be mixed between the engine, thermoacoustic engine, and thermoacoustic cooler that used for cooling like air conditioner and refrigerator inside the school. So we don't need the electricity, but we use the solar power. So the engine work because powered by the solar power, and then the result is the acoustic power, and then the acoustic power can be used for the refrigeration. It means that we can save energy without electricity from like outlet, but we can use the solar power or waste heat energy or geothermal, and after that we can use for the, for example, like this one refrigeration, which is free from CFC and safe for our earth. Okay, let me sum up my talk. So the thermoacoustic engine is a technology which is beneficial for energy saving, and then the thermoacoustic cooler is environmentally friendly. And the last one is combination between the thermoacoustic cooler is useful for energy saving and environment. And then now we need to think as a students or as a researcher or engineers. When we think like, okay, we have a truck, like that the compartment behind the truck need the cooling power, and then this is how to say, we need another source of energy. But if you think that, oh okay, we can use for the engine of the truck, and then the heat engine can be used for cooling power, or the engine the waste heat from the engine of the truck or car can be used for air conditioner inside of the car. I think it would be beneficial for saving energy and good for our Earth. And then thank you. That's all. Thank you for your kind attention. Thank you.
Okay, thank you, Dr. Ina. It's very interesting topic. During we waiting some question, maybe I will ask some questions same with Dr. Sai. How to do research during pandemic? Maybe you have some trick or you can manage your research.
Yeah, actually, in the pandemic, it's not easy to do research in our laboratory. I mean, like, we need to do, how to say, use mask and so on, and then not all people can go to our lab. But uh, recently, I focus on the optimization of the research, and then we don't need to go to the laboratory, so we can do by the computer, and then we can go discussion, and then we discuss about the science behind of the thermoacoustic engine and thermoacoustic cooler without how to say offline meeting. So in the pandemic, so it's okay to do the research. And now at now time, I think I still do the optimization because many geometry that we need to optimize before we build or we do the experiment. Okay.
Or maybe some participant have some question for you. Where is? Wait. And what is your research now? I think you have another research.
Yeah, yeah. Actually, I have some research, so I already submitted to the journal, and then I work on the another optimization related to the porosity because you know that in the engine we have many geometry, and then we need to optimize before we do the experiment or we build the devices. We already submit the like optimization, and after that I already I have done with the research related to the how to convert the noise, noise
Yeah.
into the electricity. Actually, I'm from mechanical engineering. I did the collaboration with electrical engineering, Mr. Amir and his student, and then we try to use sound. In this case, it's not an ordinary sound, but in this case, it's about the noise. In the airport, it's very noisy, and how do you think if the noise is something and then we can convert into the electricity? So in our lab in the electrical engineering and mechanical engineering, we work on this, and we already produce for somewhat. And then I think in the end of this month, we will finish for the data. And next September, I think we will submit for another manuscript for publication related to how to convert sound or noise. This is related to the acoustic to the electricity. I think it could be beneficial for us. Okay, thank you.
Okay. We have question from Septiani Wahyutami for you, Dr. Yuna. Could you tell me about the best factor of your research result from thermoacoustic engine? And is it possible if we just have room temperature as an input to the thermoacoustic engine?
Okay, sorry, Mr. Budi, could you please to repeat your question?
Okay. Could you tell me about the best factor of your research result from thermoacoustic engine? And is it possible if we just have room temperature as an input to the thermoacoustic engine?
Okay, you mean that best factor, I mean like the effect, I mean like if you talk about the factor, it can be related to the geometry or it can be related to the what gases you use. Like in the case of geometry, the best factor is the regenerator itself. If we make combination between the engine and the cooler, there are two regenerators. The regenerator is the best factor. I mean, like the factor have a huge impact on the efficiency. The first is regenerator for the engine, and the second is the regenerator for the cooler. So we need to optimize the radius. We need to optimize the how to say the length, and then we need to optimize the porosity also, because regenerators are the heart of the thermoacoustic. It can be engine, it can be cooler. Okay.
Okay, and then we have the second question from Endang. Wait. Endang Dian Rohmawati. Dr. Irna, based on experiment, how much the biggest electricity power that have produced from the thermoacoustic engine? And what is the best renewable energy for the thermoacoustic engine?
Okay, thank you. So there are two questions actually. The first, how much like, uh, as I know that for the application that try to build in the market is in the Netherlands, and then this is like startup, startup. So in Aster, you can search in the internet Aster thermoacoustic. You can find it that I forgot his name. I met him in the international workshop of thermoacoustic last 5 years in Japan. So he built a thermoacoustic engine to power, like for the electricity. And then I'm not sure about the how to say like how much. I think it's about 1 megawatt and so on. I think, but you can search again in Aster thermoacoustic, because it's a huge amount they can find for the electricity, and it can be applied in the, for example, I think in the small industry and then at home. So I'm not sure actually. I think 1 megawatt or more. You can check in Aster thermoacoustic. And then the second one is about Mr. Budi. Could you please
What,
remind me about the second
what is,
question?
okay, what is the best renewable energy for thermoacoustic engine?
Okay. It depends. If in Indonesia, because we tropical country. So you know that solar power is very good for us. So I think renewable energy like solar power is good, and then we can mix solar power with geothermal, because I think Indonesia has a huge geothermal energy. But in other country which don't have much how to say illumination of the solar, I think they can use another renewable energy. For example, like waste heat. Waste heat. All of a country they have an industry, and then in the industry, always we have the waste heat, and then the low waste heat, and then the middle waste heat and high waste heat. In the case of low waste heat, usually they cannot use it. But in thermoacoustic, we learn how to use the low heating temperature. It means like waste heat that can be used for electricity or refrigeration. So I would like to say that the best is in my opinion, it depends on the country. But in Indonesia, I think combination between the solar power, geothermal, and waste heat is good. But in other country that not have much solar energy, so I think waste heat is very good. Because if we think about like, oh, we have the car, and then the engine car. Engine car is hot, but it's not so hot. It's low. It can be considered as low hot, but we cannot use it for the converting to other energy. But in thermoacoustic, we can use the low heating temperature. For example, like it's it's possible. I think in the future we can change the heat power from the, for example, like a motorcycle. We can charge our cell phone using the heat engine for motorcycle. I think yeah, in the future it's possible. Or in our car, we can charge this using the heat from the engine. But we need how to say make some research about that. I think it's possible. Okay, thank you.
Okay, and the last question from Kevin Yapri for Dr. Irna. Is it possible to do full simulation without experimentation for thermoacoustic?
Yeah, actually, how to say, um, full simulation without experimentation, in my opinion. So at first, we need to do all of simulation at first because because before we do simulation, if we directly do the experiment, it's not easy for us to set all of the parameter, all of the geometry. So in my case, last when I was in Japan as a PhD student, so I changed many parameter. I work experimentally. So I changed the truck, I changed the pipe, I changed the regenerator many times, but I could not find the best result. After that, my supervisor, Dr. Ueda, he suggests me to do the numerical simulation. I mean, like all of the simulation, I did it, and after that, uh, how to say, I did the experiment with the master student that I show you, like three stage engine with one cooler. So they did the experiment based on the my result and other results. So, if you talk about is it okay for full simulation without experiment, I think uh, we must we must make a balance. Okay, all of first we finish all of simulation and then we get the some geometry best, and after that we do the experiment. Because if we talk about only simulation, we didn't know in the how to say in the real cases. For example, like in my simulation, I did the validation with the experimental result before, and then I think that could fitting between the experiment and then the simulation, but still there is some discrepancy that we cannot expect exactly. So in the case of experiment, we can get the real result, and then we can build the device and then use it commercially, I think, in the future, inshallah. Thank you, Kevin.
Okay, I think enough. Three questions for Dr. Irna. And thank you for Dr. Sheikh, Dr. Irna, for giving us some presentation about cooling technology. And I hope we can meet in another webinars. And I hope you can enjoy the day. Thank you. See you.
See you. Thank you very much.